So from the onset of history, philosophers were thinking whether matter and space and also time can be infinitely divided, or we have limits on how small we can go. So in this regard, there were two major points of view. One is atomic theory, and the other is a substance theory. So some philosophers believed that there must be some limit on how smaller can we go, and this is called the atoms, but not in the new scientific way, not the atoms we know today that are composed of electrons and protons, etc. But actually these philosophical atoms are utterly indivisible. So some philosophers believe that there must be some indivisible units of space and units of matter. However, other philosophers believe that all the phenomena that we see, all the physical phenomena, are actually have a deeper level, which is called the substance, which there are actually many more than one point of view in this regard. Some believe that there is only one substance, some believe that there are two or multiple. So in the end, this substance theory believes that we can divide infinitely, and therefore we have uncountable space or in continuous space. So this ancient philosophical problem continued until modern science. It appeared on many levels. For example, we believe today, all physicists believe that there must be some smallest scale called the Planck Scale, where, for example, we have minimum time or minimum distance or minimum energy even, or minimum mass, which we can't go below that. And also the continuity and discreteness appeared again also in light, or is the wave-particle duality of light and also of particles. So light itself is now thought to be waves and particles at the same time, and also particles like electrons are also have wave properties. So this duality, or these 2 points of view, are competing always through history, and none of them is really able to explain all the phenomena. And the problem is that at the same time, either if we stick to one point of view, we will not be able to really understand all phenomena, and the same if we stick to the other point of view. So we must take both together, and at the same time they are actually mutually exclusive. It's not possible that something can be waves and particle at the same time, or continuous and discrete at the same time. Either continuous or discrete. This is the main problem. And the problem is that there is no other way, at least on the physical level. So from here, we conclude, or I concluded, that we must really go to the metaphysical level, where things are not really, do not have dimension. We must start from 0 dimension. Instead of thinking on the level of multiplicity, if we start from the metaphysical, where we have no dimensions, and then we think about how can dimensions be created, or how these dimensions emerge, then we may solve this problem. And I found that this problem can be really solved with a single monad model, which explains how all the multiplicity in the world is being recreated or created by one single entity called the single monad, according to the greatest master Muhyiddin el-Arabi. So if we take this oneness or single monad, from this oneness we need to understand first how multiplicity is emerging. And the critical idea here is time, because with the recurrence of time, this unit or this one being, that is a single monad, is repeating or copying itself and reappearing over and over again in the multiplicity of the world, and creating all these physical multiplicities that we normally see on the outer level of time. So this one being, that is a single monad, is doing all this creation not on the outer level, but in the inner levels of time, and that's the importance of the theory of creation by the greatest master Muhyiddin ibn al-Arabi. So this, before I really go on to explain this single monad model, as I promised in the beginning, let me show you some of the main problems that we really need to solve, in order to understand or reach ultimate theory of physics. Now, many physicists have thought about these problems before, but then they decided just to forget them and skip them because they can't solve them. However, as long as these problems exist, we will not be able to really understand how creation is going on, or how the ultimate laws of physics. Our laws of physics currently only explain partial phenomena, but do not explain the realities. Some realities, some phenomena are quantized, some phenomena are covered by general relativity or continuous space. But if you really want to understand how things are really going, the ultimate law that governs this physical level we are living in, we really need to go beyond and therefore see how this creation is being performed, and therefore this new theory must solve these problems. So now I will pass through all these problems, and we will see very quickly that many of these problems will cease to exist automatically when we consider the single monad model of the cosmos. For example, the Zeno's paradoxes, which Zeno proposed more than 2,500 years ago, or 2,450 years approximately. So these problems, or the paradoxes of Zeno, there are actually 40 of them, but maybe we know only 4. Zeno was trying to defend his teacher's or master's thesis, who is Parmenides, who believed in oneness just like the greatest master Muhyiddin al-Arabi. But actually his main book has been lost, where these 40 paradoxes, where he presented 40 of logical contradictions, which proves that there must be no motion and no plurality. However, we have been able to study 4 of these paradoxes, which appeared on other philosophers' works like Aristotle and Plato. So Zeno proved very clearly that whether we take the continuous view of space and matter and also time, or the discrete view, we will inevitably reach a contradiction that there must be no motion and no plurality. However, Zeno himself was not actually denying motion or plurality, because we clearly see motion and see plurality. But he was trying to say that our view or our understanding of motion is not really correct. So one of the very easy actually to explain, and maybe many of you have come across this paradox of Zeno, is the dichotomy. So if you suppose, for example, we want to go from point A to point B. Now, in order to reach from point A to point B, suppose this is 1 meter or 1 unit of space. So we must first pass through the middle point. And let's say this is C. And then from going to point A to point C, we must also pass through the middle point. Let's say this is D. And so on. Therefore, we must conclude in the end, logically, that the whole distance, which is 1, is equal to half plus quarter plus 1 over 8 plus 1 over 16 plus 1 over 32, and so on. However, if you do this mathematical calculation, half plus 1 over 4 plus 1 over 8, etc., you will approach 1, but you will never reach 1. And actually, you will never even start, because you need to divide always and always. You need to divide. So you will not even be able to start motion. So, but in the end, we see motion. We see things moving, and therefore, the only logical way to go out of this is to consider that this division is not always possible. We must reach a minimum point where we cannot divide anymore, and therefore we can solve this problem, at least partially. So, however, if we suppose that space is discrete or granular, then there is another paradox which proves that this also will lead to another contradiction, and this is called the arrow paradox. So let's suppose the same distance from A to B, and let's suppose that we have an arrow that we throw, and then this arrow will reach this point. Now, and we suppose at the same time that the space between them is granular, and therefore there are certain points of space. We cannot divide anymore. So if you suppose that the arrow is going from point A to point B, then this arrow is being or exists in every point of space between these 2 points. And at every point where the arrow exists, its velocity must be 0, because if it moves and then if it leaves gradually this point to the second point, then there is a distance between them, we can divide this distance between them, and we suppose that it's granular. So it must be 0, it must exist here, and therefore its velocity is 0 here and 0 here and 0. At every point the velocity must be 0. Yet the total velocity is not 0. So here we have 0 velocity all over, and the total is not 0, and therefore this is a mathematical contradiction. So there are even more details and more paradoxes, but the conclusion is that whether you suppose a continuous space or a discrete space, you will inevitably end up with a contradiction. Now, many philosophers thought that this is really nonsense, because in the end we have motion, things are going on, and philosophers tried to solve this. And actually the new mathematics, the new calculus is based, the differentiation and integration has been developed based on this idea. However, actually until now this problem has not even been tackled correctly, because although the modern mathematics, modern calculus can do the calculation correctly with a good degree of approximation or certainty, but still it's only outside calculation, but it doesn't really solve the philosophical problem whether really space and time or matter is divisible or indivisible, or infinitely indivisible, or whether it's countable or not countable, or whether it's continuous or discrete. So these paradoxes have not been really solved yet. Again, as I said, with the recreation principle of the single monad model, this actually solves the problem very clearly, because with the recreation, things are not really moving from where they are to another point where they move to. There is no transmutation, no real movement, but there is only recreation, and therefore things are recreated in the new places. And therefore this will solve actually many problems, even for example the modern problem of non-locality that maybe we will see a little bit further below. So with the recreation principle we can start by solving the paradoxes, the famous paradoxes of Zeno, and actually I have written some articles about that which can be found on my website and some other publications. So moving on to the more modern history, we have in 1850, starting from 1850, the famous problem of entropy, or the arrow of time, where the second law of thermodynamics is clearly one-directional. However, all other laws of physics, including classical mechanics, including modern physics, all seem to be symmetrical, time symmetrical. So whether we have negative time or positive time, they seem to behave in the same way. However, we all feel the direction of time. We don't feel that we can't go to the past. And therefore, until now, we don't have real understanding of how time is flowing. Is it unidirectional or is it multi or two-directional? Until now, it's not understood. But with the duality of time theory, it solves this problem clearly, because time itself is really one-directional. However, we have multiple or we have many levels of orthogonal directions of time. So we cannot really go back, but we have time going in one direction and time going in orthogonal direction, and therefore we don't really interact with this other time. And that's why actually we have, for example, now the problems of black matter and black energy. So we have other levels of existence where time is flowing in a way perpendicular to our direction, and therefore we do not really interact with them. And this is the supersymmetrical and other levels of symmetry that I will speak about later. Then again, the main problem in more modern physics is a Michelson-Morley experiment, which proves that the speed of light is constant whether you go with the direction of the Earth or opposite, whether you measure it in the summer or in the winter, and therefore it proves that there is no effect for ether. The ancient idea of ether therefore were considered obsolete, and therefore this problem until now it's proved experimentally, but still we don't really understand why light behaves in this manner. So again, I say that with a single monad model, with the duality of time theory, we will understand exactly with the existence of ether why the speed of light is constant and why it is invariant and not related, or it's constant for all observers, whether observers are moving with or against the speed of light. Always we will measure the same value. For the same reasons that I already mentioned now, because the speed of light is actually the speed of creation, and therefore we are living on a level of time orthogonal to this level, to this real level, and therefore we will not see it. We will not be able to affect it. Just like now this things moving on the screen, like myself now when I'm moving on the screen, actually I am moving in a time direction completely not related to the direction of creation of the screen. So the screen of the computer or the television is being recreated or refreshed at a constant rate, and this is the rate of creation or the rate or the speed of light in our case. So this will not have any effect on the things moving on the screen, because it's moving in a time not related to the machine itself. It's related to the film being run or to the character that are moving. This, for example, a laser spot now, when I move it, I can move it slowly or quickly, or it can disappear here and come here, because it's being actually recreated. It's not really moving. There is nothing really moving on the screen. And this is the same really happening in our life. When we move through time, when we move through space now, we are not really moving by ourselves, but we are being recreated at every instance of time by one single entity, that is a single monad model, as I will explain maybe later with more demonstrations. Yet again, more modern problems is wave-particle duality. Already I mentioned some aspects of it. So, because the waves are continuous phenomena, the particles are discrete phenomena, and we clearly notice that some, actually almost everything now in nature have this duality. Sometimes behave like waves, sometimes behave like particle, and we still know how and when or why it behaves in this duality. With the duality of time, real time and outer time, we have real continuous which is a wave phenomena, and outside imaginary, which is a particle phenomena, and therefore the problem will be solved very easily with the duality of time. Yet another more recent problem is a magnetic monopole. Until now, this problem is not solved. This problem appeared by Paul Dirac in the 1930s when he developed the quantum field theory based on the famous Einstein equation E = mc squared. Actually, the problem is that because we don't really understand this mass energy equivalence, and we take it as granted, we take it as part of the theory of relativity, when actually it is not, because it's the secret of quantization. And that's why Paul Dirac was able to really discover with this equation, when he included this equation with quantum mechanics, he was able to discover the positron and therefore the supersymmetric, or actually this is not yet supersymmetry, but again the other particles, he discovered it by symmetry, and then this opened the door for more particles to be discovered. Until now we understand how all the particles, we arrange them in the standard model of elementary particles. So with this, in this model, until now we still don't understand why we don't observe a particle that have only one magnetic pole. All our magnetic phenomena have dipoles, north and south. Whereas, for example, the electric properties can be positive and negative, and they can be separated without any problem. We have electron, we can separate it from protons and others. So we cannot now separate the magnetic north from the magnetic south. And this is a big problem, because since electricity is quantized, why not magnetism should be not quantized? Especially that actually we don't have as a fundamental force or interaction, we have electromagnetism. So we have only one force together, it's one interaction. Therefore, they are closely related to each other. But still, until now, we have not noticed or discovered any monopole or magnetic monopole. With my new model, we will understand later that the single monad itself is actually a magnetic monopole, and it's only one and unique. There is no other magnetic monopole in the whole creation. There is only one magnetic monopole, and then because this is actually the 0 dimension, and then when it multiplies to the second 1 dimension, 2 dimensions, 3 dimensions, as it creates more dimensions, the interactions become different. So, for example, in the 0 dimension, we have the magnetic monopole. In the 1 dimension, we have the electromagnetism, and then second dimension, we have the electroforce. But actually, because the second dimension is a plane, we have 2 directions of it. So we have weak and strong nuclear force. And then in the 3rd dimension, we have the gravity. And actually, this same problem, this same idea solves the problem of hierarchy, because now we still don't understand why these different forces or interactions are way different from each other. Some of them are very big, some of them are very small. For example, gravity is really very, very small, whereas electromagnetism is much stronger, and the nuclear forces are really much, much stronger. So why there is so big difference between these different interactions? The answer is because they are properties of different levels of geometry. So not only gravity is a property of geometry, but electromagnetism, the weak interaction and the strong interactions, all of them are properties of geometry, starting from the magnetic monopole, ending with gravity, and also maybe extending further to other more higher dimensions like 4 dimension and other even. So this will lead us again to more recent problems, and that's the problem of Young-Mills existence and the mass gap, which is also related to the elementary particles, the standard model. As I maybe mentioned, in the standard model, we have particles with mass and particles without mass, like bosons without mass and fermions with mass. But still, we don't understand why fermions have mass. The Higgs mechanism explains why some particles can have mass. But the Higgs mechanism itself does not really explain why the Higgs itself have mass. So we don't have really now a good understanding where mass is coming from. This is this problem is called the Young-Mills existence problem, and the mass gap is related to at least on the mass scale we must have a gap, not continuous. And this is explained in the single monad model very clearly, very easily, because the monad itself is a bosonic, have zero spin, but when it combines at least 2 or 4 or 8, it doubles, and therefore it creates physical dimensions. We can't have, for example, less than 2. So from 1 to 2 we have a gap, and therefore from 2 to 4 we have another gap, and so on. So we must have a gap for a minimum mass, and that's why also space-time itself is quantized, and with this Young-Mills conjectures will be actually verified, and it's correct. He conjectured even in 1964 that the points of space must be separate and can be combined together to make a discrete symmetry, and therefore we must have a minimum mass for the particles. This is actually the same problem of color confinement, why for example, quarks cannot be separated, and also this is also related to the problem of renormalization. But now with this granular geometry, we don't even need renormalization, because we have a minimum discrete symmetry. So these are some of the problems in modern physics. Let me continue with more problems, but I will pass a little bit faster, because I want to really go to the main points of our discussion today, that is the single monad. So we have also the horizon problem. This problem doesn't actually exist in the single monad model, because with the recreation, we have internal time, and therefore all the states in the universe are being synchronized internally before they appear on the outside. This problem is now known here in cosmology and astronomy as homogeneity, or why the universe is homogeneous. Now the universe is very large, it's very big. Yet when you look in one direction and you look in opposite direction or in completely far areas of space, you see the same kind of stars, the same kind of galaxies, without any possible interaction between them, because the distance between them, to be able to have any interaction, you need much larger times than the age of the universe. Yet at the same time, the universe is homogeneous. So in the single monad model, because of the recreation, there is internal interaction or internal synchronization before it appears on the outside. So no matter how large the universe could be, it must be homogeneous because it's created by one single particle. That's why it's very easy. Another problem is the problem of spin, the spin crisis. We still, until now, we don't understand how spin, what is the meaning of spin, especially the quantum spin. In the single monad, this is this can be explained, at least potentially, but it's now very difficult to discuss here, so let me skip this point. The cosmological constant problem, again, is one of the problems. This constant has been proposed by Einstein when he wrote his theory of general relativity, his field equations in 1917 or 18. So he supposed that there is a constant to balance energy. However, he later regretted that because he said that the universe is expanding, so there is no need for such constant. That's why he considered it at some point that it's one of his biggest mistakes or blunders. However, in 1918 and 98, some experimental measurements proved that there is really a non-zero cosmological constant, but actually it came out to be really very, very small, comparing to the expected value from quantum mechanics, which is known as the vacuum catastrophe, because in quantum mechanics, the same issue of cosmological constant, there it's called the vacuum energy. Actually, it's infinite, but it can be calculated to a finite value if we suppose a cut at some, for example, at the Planck scale. But yet, even at this scale, we have a very large value. Comparing to the measured values, the ratio, the difference between them is about 1 to 120 orders of magnitude. So it's really very, very big difference. It's the worst expectation. And yet, this can be easily, it is a huge difference, can be easily explained in the single monad model, again because of the recreation. And the key here is, instead of doing the calculation of the vacuum energy, instead of summing all over the states of the whole universe or the unit of volume, we don't need to sum because it's being recreated chronologically. So we need actually to take only one state. So instead of summing, we need to take the average, which is a big difference. And actually I found by accurate calculation that the difference is exactly about 120 or 118. So the difference becomes very small between the measured value and the expected value. We already mentioned the hierarchy problem, why the gravity is very weak. And as I said, this is because the gravity is on a 3D level, but other particles, other interactions are on lower levels. So we also have the parity problem, which is related to the arrow of time. Let me skip this. Dark energy and dark matter are also related to the cosmological constant problem, but with a new model of single monad, we have higher levels of symmetry where we have supersymmetry, which solves the dark matter energy, the dark matter problem, and we have hypersymmetry, which solves the dark energy problem, and also it can solve the dark flow. But let me now not comment too much about this. Finally, the problem of quantum gravity is again automatically solved because we have now quantum or quantized geometry, quantized space-time, and therefore geometry. Actually, the theory of relativity is the theory of gravity, and since now the theory of relativity is based on quantized space-time, it becomes quantum gravity. Automatically, quantum relativity, automatically we will have quantum gravity.